Welcome to Becoming an ML Platform Power Builder, powered by ML Observability. With me, I've got these two lovely speakers. To my right is Aman Khan. He is the Group Product Manager at Arize AI, working across engineering, design, and go-to-market teams to develop a highly scalable ML observability platform for the modern-day ML stack. Sitting beside him is Gandalf Hernandez. He's the Senior ML Engineer at Spotify and is a manager with the ML platform team there, focusing on driving the feature store and model-serving teams. Fun fact, they both worked at Spotify previously. So I'll just hand it off to them, and you guys can do your thing.
Awesome. Can you folks hear me okay? Okay, cool. Thanks, Sean, for the introduction. As Sean said, my name is Aman. I'm a product manager at Arize. Just a quick question, show of hands, how many people have heard of Arize? Okay, we got a few hands. So I think we're probably the only ML observability product in this conference. I'm just kidding. There's quite a number of them out there. But what we're going to be talking about today is actually a little bit about the roots of building an ML platform. What are some of the needs at a large enterprise? And then how do you actually go out and make decisions about which products to either build or buy? And I'm joined by Gandalf. As Sean said, we used to work together previously at Spotify. And Gandalf, do you want to give maybe just a quick introduction in your own words?
Yeah, hi everybody. Thank you all for coming. I'm Gandalf Hernandez, engineering manager with the machine learning platform team, where the teams I focus on are building out our feature store and our model serving, but we're all part of an overall larger ML platform team, and we look at everything from training to prediction.
Awesome, yeah. And so Gandalf and I worked together for a couple of years. I was working on the feature store at Spotify, but Gandalf's career at Spotify is quite long and illustrious. It's what, close to 10 years or a little?
Close to 11 years.
11 years. Gandalf, could you tell us a little bit about the early days of building an ML platform? What was that like, at Spotify, a big company?
So yeah, in the early days, there was no ML platform. If you wanted to do ML, you were pretty much on your own. The first steps that Spotify took into machine learning, which is probably maybe 9 years ago or so, was to do embeddings and matrix factorization, and there we really had to build everything completely from scratch. I don't know if there are any Spotify users in here, but really the first thing that was ML driven was actually the radio, but the real where really exploded was when Discover Weekly came out, and I forget the exact year, but all the teams that were doing machine learning, you had to build everything yourself. If you wanted to train it and you wanted to schedule it, you had to come up with that. We had strong data tooling, but it wasn't really geared towards machine learning. When you wanted to serve up your model, you had to figure out how to get your latest trained model into your backend service. Presumably, you're going to need data for your predictions. You had to figure out to load up the data into a store that was fast enough for you to be able to pull them out for real-time predictions. And to close your training loop, you had to log your predictions, try to figure out what your actual outcomes were, especially if they're delayed outcomes. And observability was, in some ways, maybe a little bit of an afterthought, because once you had closed the chain, you're like, oh, it's working, and then it had taken enough time. So Spotify started seeing more and more a need for a common platform, because all the teams were resolving the same problems over and over again. So around 3.5 years ago, Spotify spun up a machine learning platform team. And we there started focus. We broke the machine learning workflow up into a couple of discrete areas. So we had one group that focused on model training, one group where Aman and I worked focused on feature stores, and that include also creating your training and your test data set and your splits and all of that. One team focused on our model serving, and then we had a little bit of the embryo of some type of observability platform. A lot of there was more keeping track of your training. Some was out in production. I don't know how many of you here have seen or have been involved yourself where you train a model, you paste something into a spreadsheet to track your offline metrics, and then you try to figure out, okay, which model is actually running in production and how is it behaving compared to what my offline data said. So we had a little bit of a kind of model management system built in.
Yeah. Could you give us a sense, for folks that maybe don't have the entire context on Spotify's ML use cases, like what does that scale look like at Spotify? How many teams do you work with? What's the prediction volume? To the degree that you can share publicly, but it's not just Discover Weekly anymore?
No. So since then, machine learning has kind of exploded in use. There are kind of like the use cases that you would expect. We want to show a list of tracks to you. Often those are ranking problems. But there's also a lot of, what type of sign-up information should we give to you? There's machine learning to classify incoming support requests, so that we can learn where maybe our product could be better. There's machine learning to figure out if we think your mobile connection is about to go bad and you're going to get stutter, so that we can preempt that. So there's, and of course, fraud detection, fraudulent accounts, and so on. The volume is significant. It's very significant. Probably the homepage is the biggest. Home and search are the biggest use case in terms of traffic, and we're talking about hundreds of thousands of requests per second. Might even peak over into the millions. And it's interesting because when it comes to scalability, Spotify has a lot of experience with scaling up backend services. So scaling up predictions in themselves, like having an API that can take 100,000 requests a second, is I don't want to call it a solved problem, but it's something that there is a lot of expertise in dealing with. But ML definitely adds additional complexities on top of that traffic.
Right. That was going to be my next question is, with all of this scale, trying to do ML at scale is like another order of magnitude or another problem on top of that. Can you talk a little bit about how scale fits into your decision on which components to kind of focus on in the ML platform? How does scale fit into those pieces?
Yeah. So often if you're doing, at least in our case, we're doing regular backends, monitoring becomes, I don't want to say easy, but you can trigger on, I'm getting too many errors. It's like your endpoint will fail or not, or it will be too slow or not. And you can put up monitoring rules for that, and you get alerted. But usually when a machine learning model in production starts going wrong, it won't fail. It would either slightly degrade or give, or in some cases give nonsense predictions. So definitely when you have that much scale, you can't really manually check stuff, so then you really need more of a full-fledged observability platform that kind of goes beyond what you would typically need for just regular backends.
Yeah, I was just going to click this slide because that actually seems relevant to anyone who hasn't tried Arize yet. It's actually, if you just scan that QR code, that's actually one way that you can actually get started with ML observability today at scale. And Gandalf and Hernandez can maybe attest to a little bit around having, if he's spun up with Arize, or any thoughts on that.
Yeah, Spotify has been partnering with Arize for a while, with a couple of teams that have been evaluating the product, and it's really looking to solve problems that we have, but are very hard to quantify. So that if you have a feature that is drifting, like your model is not crashing, but if it takes you a day or a week or sometimes indefinitely to figure out that something is slightly off with your model, what have you lost? Like you may not fully know. And Spotify has had examples of that where we've had models that were trained with one encoding of an ID and then used another encoding for predictions. And it's been really hard to figure out when that actually happens, because the recommendations, because they have so many other features in there, work well enough. But what is a 1% unnecessary degradation in your model performance? What does it actually cost your company?
Yeah, and I know we've definitely talked at some happy hours and coffee chats about some of the more crazy examples of what happens when a model fails at scale, which is something that is pretty unique to being in a company that has hundreds of millions of monthly active users. Can you talk about, like, 0.1%? Maybe that's not a big deal if it's just a small amount of traffic, but what happens when a model fails massively at scale?
Yeah, this is quite an old example, but so because Spotify uses, we use a lot of embeddings for recommendations. So we embed our tracks, our artists, and our users into this multidimensional space, and we often use that as candidate generation. Give me a couple of thousand tracks that would go well with this user. You pass it into another model as a more tractable data set to then do your ranking. So what ended up happening is the track embeddings were from the previous day, and the user embeddings were from today, and they got mixed up. And it just happened, and then we generated Discover Weekly. Everybody got their tracks and so on, but it just ended up being that for most people, like in Western Europe and in the US, if you listen to moderately popular music, their user vector ended up landing close to the Thai music vectors in the tracks. So everybody's Discover Weekly one day had mostly Thai music. So everything worked. But
like music from Thailand,
yeah,
like not even.
So I'm sure there were some Thai artists that had a really, really great week. But it's a good example there of everything generated, and what type of metrics are you looking at, and what type of, at that point we didn't really have much observability to see, hey, something has gone haywire. And that's where I think observability is so important, and often companies move fast and you want to ship things, and observability and like a deeper understanding of your model is kind of like you really feel the value of it after you've had an incident. So it's important to, as you're building things out, to kind of build out with observability and understanding in mind. And I'm sure we're going to talk more about model explainability and understanding and things like that.
I was going to ask, we've kind of been throwing this term around ML observability, but in your words and at Spotify, what is observability?
Observability is a very broad term. So it becomes a little bit what you want to make, or you can put everything under there. But for us, some of the key things is understanding what our model is doing when it's in production. So there are some kind of like obvious things like, are my features drifting? A lot of our predictions a lot of inputs into our predictions come from real-time data. What is the last genre the user played? If a service over there is having a bad day, it's getting overloaded or having an error, we want to know about that one of your input features are degrading, because you might not catch that in your training, because you may train off of your logs from the previous days. So can we figure out that there's feature drift going on sooner rather than later? Same thing if the shape of your predictions markedly change. That's something you would want to know. And of course, it then gets into all like algorithmic bias and fairness. Can you look at, are we treating all the groups involved fairly? And for us, that means both looking at our users in certain countries getting just worse performance on the model, like the model just, the predictions are worse off. That's something we need to know. Or is it premium users versus free users, or users of certain genres or age groups? But it's also important to look at it on the artist side or the podcaster creator side. Are certain groups being treated unfairly where, the prediction power for a certain group of podcasters or a certain group of artists is not as strong as for other groups. That's critically important for us because we want to make sure that all the groups are treated very, very fairly. And then, of course, explainability. Like, models get complex.
Right. Yeah, I'm kind of curious. Like, when it comes to all of these various surfaces we talked about, data quality, and the shape of the data, and drift, which is how much the data changes, fairness, which is how the model is predicting over certain groups over others, explainability, the importance of certain features. How do you kind of reason about trying to monitor or observe all of this? Like, how does that look at such a large company with so many large models? Like, what does the future of that look like? Maybe a little bit.
It's hard, and a lot of teams have today kind of come up with their own. You have access to all the data, like all the predictions and your outcomes. But teams have become like left on their own. It's like, hey, here's tooling for you to look at fairness and bias or explainability. And now the ML platform Spotify is really doubling down on observability, and we want to just bring in like the best practices and more common tooling. It's often still up to the individual teams to kind of decide on what are you going to slice on? What do you care about? If we give you an explainability that says that this variable has a huge impact on your model, it may be perfectly fine, but I don't know if that feature correlates with certain demographics or anything like that. Then that's a signal for you to actually like dig into more. Are you treating certain groups fairly or not? So it's technology, but I think it's also a lot of like education, coming up with best practices. We do a lot of courses. We have what we call an engagement team where we go out and we sit with the teams that do machine learning and kind of walk them through the process. Starting out with, oh, you want to do machine learning? Do you have a target metric? Sometimes that's not the case. So it's a whole. Yeah, it's not just technology.
Right.
It's very important.
You can't just get the product out there and expect it to work. And if I recall, I think a lot of what you're describing, when I was there at least, it was mostly done in like notebooks. It was pretty ad hoc. Like, is that still the case? Like, is that sort of?
A lot of it is still in notebooks. So we've focused on kind of like making sure that you have access to all the, like solving the scale problems. If you're taking 100,000 predictions per second and maybe you have a delayed outcome, like did the user sign up for premium within the next 2 weeks, we can process those huge data sets for you to kind of create your outcomes that you can then, of course, train from, but also learn from. But it's still been a little bit that like, here's all the data, but you still have to kind of analyze it. And I think now we're moving more into a world where we want to be able to give tooling to teams to basically not have to jump into the notebook as soon as they want to understand something.
And you kind of touched on this earlier, but you mentioned model serving at scale, handling large amounts of predictions and volume, even feature data. There's kind of some paradigms around that already at Spotify, and observability is really the piece that you're looking to invest in. Could you talk a little bit about like the parallels? Are there any of observability or what you're building and what you're working on to sort of standard like DevOps, or how do you think about that from the perspective of what's similar about observability, but also what's maybe different in today's paradigm?
So I think the similar about observability is it's often been an afterthought, right? Something is out, you're like, we shipped stuff, cool. And I think a key part is to give our users as much out of the box as possible. So if you look at on the typical backend side, if at Spotify you spin up a new backend service, as soon as you put it into production, you have a couple of alerts set up. And if your P99 goes over, I think at default it's like 500 millisecond, you'll get alerted. If your error rate goes over, I think it's 2%, you'll get alerted. So as soon as you ship something into production, you have some guardrails. And I think we want to move to like machine learning to kind of have that thing too. That if you ship a model, there's stuff that we could that you kind of get out of the box to start out with. So if you build a model and you ship something and say you build a classifier and it just says no all the time, we should be able to kind of catch that out of the box for you, and then potentially maybe point you towards so that okay, actually look at what your data is, tune your observability criteria. And a big part is also to just be able to go in and see how your model is doing in real time to kind of help with the online-offline correlation. So you train a model offline, everything looks good. You want to, as soon as you put it in production, you want to see how well that correlates with what you hoped were happening.
Right.
Was happening.
And I guess this is where the product manager in me starts kicking in a bit, because when I was there, we were trying to quantify why is this a big deal? Why should we invest in observability? And like when you think about like Spotify's business model being so related to kind of, if you're losing customers, you're churning customers because of negative experiences in the app or poor recommendations, that's a direct cost to the business. Like, how does this sort of play out in the business case in an organization which is so complex, 10,000 employees around the world, maybe not everyone cares about observability. Like, how do you kind of rationalize that?
I think in the end, everybody cares about the same thing ultimately, is that we want to give our users the best experience. And big part of that is, of course, that to have like a very nice app, have as much content available as possible, but because there's so much content, the recommendations become this entry point into pretty much everything that you do. A huge chunk of Spotify's consumption comes through the start page. If you're a Spotify user, it's like a bunch of shelves with items on it. So if the users get a bad experience there, like it kind of taints it taints the whole experience. So it is very, very important for Spotify to make sure that all our users feel that, yeah, you get me. And and it's amazing sometimes when you go in, and I'm a huge Discover Weekly fan, and I click on the first song, and it's an artist I never heard, and I'm like, and I discover a new artist I've never heard. That is something that I will remember. So getting these recommendations right is just really, really critical for us, for our relationships with our users.
Right, and actually you're touching on something kind of interesting, which I think we've been talking a lot so far about how to catch when things are going poorly. But just hearing your experiences, machine learning does a lot of good, and you kind of want to know when you're doing good for your users, and which features are important, which slices are important.
Yeah, and it's also really hard to understand what does it mean to do good. And sorry, I keep coming back to Discover Weekly over and over again, but say that you train a Discover Weekly where you want to maximize consumption in that feature. You can set it up as your target, you can train against it, you can do observability against it. But maybe the best experience was the example I just mentioned. I click on it, I hear the first song, I love it. Then I spend the next week just listening to the artist. I maybe click on the merch page and buy some concert tickets now that the world is back open again. So even there in observability, is there some way to capture that you may have multiple objectives that you're trying to measure.
Right, and the system is like inherently dynamic, right? So you're interacting with the product, you're giving sort of feedback on, is this model kind of doing what you want it to do? But you also just touched on, the world is back open again, and the environment is changing. People change, the environment is changing. How does that fit in with model performance and how you look at this problem?
I think definitely like consumption patterns change. Suddenly everybody's going out again. I mean, the typical example is, no matter what music you listen to throughout the end of the year, throughout the year, come Christmas, everybody puts on Mariah Carey. I'm sorry, which wreaks havoc on a lot of the models. There's been a lot of work to classify Christmas music and sleep music. I've spent months trying to classify sleep music in a previous team at Spotify.
And like kids music
kids
too,
music
right?
also,
like,
yes.
Parents and
But it also means that hopefully, because you now have a tight training, evaluation, deployment loop, you can catch these changes as they come quickly. But it also means that your model could behave quite differently from one week to the next. So then it's like, do you have an observability platform that can first maybe tell you that something is switching? Maybe some of your input features suddenly become super important while some other ones are not, or the shape of some of your data changes. And now if you have a platform where you can see that, you might say, oh, cool, it's fine, and I understand why. But it could also mean like, wait, what's going on? I better dig in a little bit deeper. And maybe an example there would be, this is quite a few years ago now, but suddenly like when the whole world listening to Gangnam Style, and suddenly like all users and all our models are like, hey, listen to this particular song. But if, it could have also been an error, right? Suddenly, like your model is like everybody's recommending this random song from a different country for most of the users. So even there, even if good serendipitous things are happening, you still want to know about it.
Yeah, that's really interesting. It's almost like, this only just brings me back a little bit to this whole concept of like PagerDuty, or like, there's something wrong with your application, go in and fix it. And there's SLAs around that for like back-end engineering and operations. Your model or your application is performing incorrectly, go and figure out what's wrong.
Yeah.
And with ML becoming more and more core to businesses, do you kind of see that happening at companies like Spotify Scale, where it might actually be important to get a page to get monitored or alerted?
Yeah, it definitely is. And out of the box, because in the end it's still running on backend services as APIs, there are still data pipelines that generate training data set, prediction data set. So if things go completely wrong, you get that alerting. But I see us moving more and more forward to being able to alert if. And today we have some instances of this, like if a feature starts drifting, you may not, if a backend service acts up for a couple of minutes, we can learn that. But can you within 10 minutes or 30 minutes say like, hey, something is up with your predictions, the shape of your predictions, especially if it's classification or something like that, has markedly changed. Fire off a PagerDuty, because in some cases, if you're doing just maybe some recommendation for some music, it may not have an immediate impact, but you may have an ML model that is on your sign-up page. So if you're losing a couple of percentage points there, you're potentially losing out on thousands of users.
Or if there's a new campaign that launched, like I remember before I left, like last summer, Kanye West drops a new album called Donda, and you try to search for Donda, and there's an ML model that doesn't recognize this as an input, right, as an input feature, and that's something that's almost a real-time sort of use case. Like, is that something that you're kind of seeing as well, more real-time?
Yeah, and one of my feature store teams, one of them, we're focusing a lot on this real-time aspect of data. We wanna be able to kind of feel like we know you right away, and not just, oh, you listen to one Kanye West song, here's another one, but we want to be able to update your user profile in real time. And that brings in a lot of more actually observability issues into your platform, because now you are calling out to other services, so you have streaming pipelines, and there are latencies in there, or sometimes problems that you may not be able to catch with a static data set. So that makes observability even more important.
Right. Well, it sort of reminds me, like, we've had so many of these conversations, and really want to thank you for your time. And we have a little bit more time here left, but I kind of want to touch on what you're kind of coming to is that observability seems to be like a very cornerstone problem to work on. And what can you share about your learnings from almost 11 years at Spotify how do you think about the build versus buy analysis, and what learnings can you share with this audience, on about your journey along the way?
I feel, and it's my personal opinion, but I think it lines up pretty well with Spotify's opinion, is that really our strength is in Spotify has been around for, I don't know, launched in the US almost 11 years ago. So we have a ton of data around our users, our artists, the interaction between them. We have amazing teams that analyze the audio of our songs and of our podcasts. And we built up a lot of expertise into like how to tie things together when you're building a new feature as in something that's going to the client, not a data set, like what makes for a good feature. That's our advantage. Our strength is we're not going to make a better TensorFlow, or we're not going to make a better XGBoost. And Spotify has traditionally been looking at, we call it standing on the shoulders of giants, where we use both open source and commercial software that is available to build on top of that. And ML Observability is one of those areas we've done a little bit internally, but we're also looking at what is out there in the market, because it's an opportunity cost, everything, right? It's like, and I think it's very important to think about build versus buy. And having been in infrastructure for quite a few years at Spotify, it's a lot of fun to build infrastructure. The first 3 months, the first 6 months are awesome. You build stuff, you get to come up with cool ideas, you get one or two other teams excited about it, and they jump onto your infrastructure, and then you want to change something, but you can't. Or the scale goes up, and you start getting on call. So it's for us, it's very important to be very deliberate about what type of infrastructure we build, because those decisions have long-term repercussions, and that's where it becomes so important to like look at what should you build and what's out there already in the market, and how can you, and how would you tie it into your own technology. And also a very big part is, like, does the philosophies line up? Like, Spotify is a very, very autonomous company. Most teams can do whatever they want. So if the ML platform, we come and say, you have to do it exactly this way and exactly this way, that's not going to fly. So when you're looking at outside tooling, do their philosophy kind of lines up with your company's philosophy? It's a very important thing to look into.
So it's almost like at Spotify, you want to focus on what your core business model is, what you guys do best, which is understanding how people listen to audio and appreciate music, and kind of outsource the stuff that might not be core to that business model.
Exactly. With Spotify, we built on top of our deployments are on top of Kubernetes. Spotify is doing a lot of stuff in TensorFlow. Our serving infrastructure underneath is based on TF serving. Our backend service are gRPC. Like, you find out what's already out there, and if it fits, use it, and then build the additional pieces on top to either integrate with the rest of what you have, or if it's open source, contribute back.
Yeah, and maybe just on this last note, and then we'll take some questions if folks want to start lining up. We have about 10 minutes for questions as well. But you touched on something earlier, which is, as an infrastructure team, you can't just build the infra, you have to actually get adoption for it. Yeah. Like, what can you tell us about what that looks like at a company? I remember over 50 teams using ML and the platform. Like, any advice that you can give, maybe a few lines of what that looks like for companies that are just getting started with their own ML platforms?
For me, the saddest thing that can happen when you're building infrastructure, you're building a flat platform, is that you build something and you think it's amazing and you put it out there and it's just crickets, right? Nobody comes, nobody uses it. You may have an idealized world view of what the world looks like, and you forget how dirty it is, how many hacks there are. So for us, we always try to find an initial customer for our product. So if we're gonna build something new, let's find one team, maybe two teams, and build something together with them. so that our problem changes from, oh, I hope we'll get some adoption, to like, well, I know I have one customer, and now my problem is to make sure that I'm building something that is generic enough for a large enough audience. And I've found that problem to be a lot easier to deal with. And it's also then, as soon as you have your final commit, you also now have a customer, so you can see how things work in production. So I think it's also, it gives you that little bit more of an instant gratification, which I think is very important. So I would definitely say always try to build with your customer in mind. And sometimes, like when you and I started, we joined together because the team was small back then, and there was, I think, more than half the engineers came from another part of Spotify that were going to use our tooling.
Yeah, and it's interesting because I feel like as a product manager, you're always told like, oh, find a problem, find a use case, solve that. But it really comes down to people, right? You got to partner with those people because they're going to use your tool and they want to help build it. And that was a really interesting realization there.
You still have to make sure that you focus on the right problem, but then it really helps you anchor it into reality.
So we have a few minutes here for any questions on ML platforms, observability, scale, or any more fun Spotify stories. Feel free to ask Gandalf. The microphone is in the center of the room here.
Hi, this is Said. Thank you for the talk. 2 questions I have, if I may. The first question is, or maybe I missed it. How was your experience of using managed platforms to expedite your journey for the data science or machine learning? The second question is, how do you consider the impact of competition when you're using their infrastructure? Like if you're using some of the infrastructure by the vendors provided that might be your competition. How do you feel about sharing data on their infrastructure?
So I guess the first question was
it was around selecting managed platforms?
Managed service. It's a little bit. I think you have to kind of look at it on a case by case basis. Like if you do a fully managed solution, your life becomes a lot easier, but then you also have more constraints. Right? So we usually try to do is semi-managed as much as possible. Like I guess everything in the end is built on top of the cloud. But is it, do you put in VMs or do you buy a hosted like a fully supported solution? And I like managed solution because it's you own less code and there's less maintenance and there's somebody else you can call if things go wrong. But you also, I think, have to be mindful of what freedoms are you giving up. When it comes to competitors, Spotify's on GCP. I know Google has a music service, but I mean there are strong firewalls in between that, and if cloud providers can keep track of people's like banking data.
Yeah, it's almost, maybe that's something to check before working with the infrastructure or the service is like make sure that they actually have those processes in place, that they're not going to do, like that's probably something to check in the contract phase, but it is a good thing
and
to check.
It's something above what I think about, to be honest.
Hey, how do you justify your team's impact and the platform's impact, especially early on when you're first starting?
Sorry, how do I justify?
How do you justify your team's impact, as in hitting KPIs, like goals, that kind of thing? Like how do you actually justify that when you're a bit separate from the use case that's being delivered directly to the customers?
That's a good question. For us, we have a lot of demand from our customers where they say, hey, we're the search team, we're the home team. We need help. We need help there. So there's we haven't really had to justify our existence. And in some ways, if you're a platform team, if you can keep good track of who your customers are, in some ways, and we don't always have to really quantify it, but their successes become your successes. So overall, in general, we have obviously we have metrics and adoption numbers and things like that, but I feel like there's just such a pent-up demand for infrastructure around the ML that you don't have to justify it.
Yeah, so I'll give maybe a slightly different opinion, which was, when I was product manager on the feature store, going from 0 to 1, the way that we thought about it was what's out there and looking at the landscape of use cases at the company. What can we possibly cover from that total market? And then what's the first problem we're going to solve and the impact of that on the company? So it was, the customers
I
were
guess,
there.
I guess nobody is questioning your existence, but there definitely is a lot of discussion about what you should focus on.
Right, right, exactly. And so, making sure that you're focusing on the most important problem, maybe not the easiest one.
And it's also important for us that we have a coherent platform. So there are important use cases that we have said we understand this is important, but it's outside of our domain, because bringing that into our domain is something we're going to have to live with for many years. So sometimes it just means having to say no.
Yeah, and there's always ways to connect it to like business impact or like risk or quantifying cost, and exercises to go through there as well.
Hi, I just want to ask on the build versus buy discussion. So where do you draw the line between something to build to give you a competitive edge versus using kind of an existing solution, whether it's open source or not? So, we talked about data, obviously that's, let's say, the golden egg, but also kind of the way, the model architecture, the way you deal with it, even the way you develop the model, can actually give you a competitive edge. And even with observability, for example, how do you know that potentially building your own solution, you'll be able to detect drifts, kind of, finer detailed drifts a lot more efficiently than, say, an existing solution?
I think Spotify, we do have a lot of ML, like the ML platform is quite sophisticated, but we're also not at the point yet where we're chasing like minuscule like improvements. There are like some areas that just where there isn't much at all. Like build versus buy, it's evaluate your vendors, like try them out, bring them in. A lot of vendors will work together with you to set up a trial, show your customers, hey, does this solve your problems? We do a lot of piloting because if you obviously there is an integration time, but we also want to take into account the time take to build it. Is it better to have a solution in 3 months that solves, I don't know, case to 95%, to wait 2 years to have something that you feel is perfect? And chances are by that, especially in ML where the landscape moves so fast that teams may have moved on to and now have different needs.
Yeah, take those quick wins when you can. And so I think we have time for one more question.
Thank you. This was really good. Some of the things are a little bit unclear in my head. Like some of what you want in the music, like you said, like Discover Weekly, is supposed to be something that you haven't heard of. It's interesting, and you hear, and it delights, right? So then when you have a drift, when something is like slightly changing, how would you measure the effect of that drift on something as ephemeral as delighting a customer? Like it's kind of hard to measure and then say, oh, like my model needs to be fixed now, or there's something wrong. I mean, the example you gave is very clear cut, like Thai music and but otherwise.
Yeah, it's tricky, and especially when it comes to like embedding models. What does an embedding model drift look like? I don't think I have a good answer for that. Like I can tell, like if it's if it's a classification and starts drifting, you see something happening.
Yeah,
but
exactly.
no, when it is like recommendations, especially if it's like more long-term, like user happiness and stuff, it's hard. And I think that's why a lot of the teams have strong data scientists that look at things not just from my model was trained to this metric, but let's look at overall retention and look at consumption and lifetime user values. So
But that's not like a small drift. Like
no,
a drift
it's not,
by nature is like sort of you're moving slowly, right? So then you have to wait a little bit to see.
Yeah, no, it's hard. Yeah, I don't have a great answer for you. If you have one, I'd love to hear it.
One interesting thing, not to immediately plug Arize here, but one thing we do is, as sort of being a single pane of glass across your model and all of the respective features, is you can go in and look at the drift and impact of that feature on your model performance. So with embedding features, you might be able to see, is this particular feature actually impacting my model performance disproportionately than the other ones?
Yeah.
And so you could, as a sophisticated data scientist, be able to build those correlations between drift or data quality and overall model performance, and then linking back to the business case as well.
Yeah, and there is also you may be able to detect it within a couple of minutes, but there still are a lot of
There's a lot of noise there. If somebody doesn't listen to a song, maybe it just means that they're not in the mood for it now,
Yeah.
right?
I think on that note, I'd love to learn more about your use case after this. So if you're free, would love to chat with you. And I think that's all the time we have. So thank you, Gandalf, for your
thank you.
time. Thank you, all of you. And